square kilometers of surface area at the top of the hole, which I believe is much bigger than downtown Santa Barbara. Please look up. I'd like to highlight a few things in this picture. First of all, you may see Salt Lake City right there. Second of all, you see this mountain range, and if you look in that valley, it's suspiciously flat. So is this one, and so is all this, because that's all tailings. That's all the stuff that came out of that hole. That hole is 800 meters deep. How many? What fraction of a mile is that? About a little bit more than half a mile deep. I believe that this is copper, but I'd be happy to be wrong.
It's like 12 feet short. Yeah.
Okay. And look at this little switchback road that goes down into the ground. I'd like to explore that for a moment. So, when you see those roads, remember that they're made for mining trucks. So to put that in perspective, there's a school bus at the same distance as a mining truck. You use those to move the people. So when you see that road driving down there, you're like, yeah, I could drive down that road. But there's a Tacoma behind a mining truck. So 2-lane mining truck road is the same roughly as a 10 to 12-lane highway.
It's so weird how it makes it just look like a toy, like automatically.
Yeah, I totally feel that. I know what you mean. I mean, look at that thing next to one of the wheels. But to put this again into scale for you, look at one of the engineers. They're not called drivers because they don't drive them. You have to climb up that 20-foot staircase to get to the quote-unquote command deck. The command deck doesn't have like a steering wheel. It has like a bunch of screens and desks with levers.
It's like you're on like a ship.
Yeah, it's just like a really large boat. If you were to fall out of the driver's seat and step down to the ground, you'd break both of your knees. That's in the ballpark of 20-odd feet from the driver's seat to the ground. So again, like when you guys look at that road, like I want you guys to put this in a scale here. That switchback road going down, that's like not a road like where my Tacoma could creep down it in first gear. That's like a highway that made switchbacks. That's really wide. The trucks that drive on that, the bed of that truck is almost the same volume as this classroom upside down. A little bit less. So you can shave about 15% off that way and about 10% off this way. But that's roughly the volume of that. So that scoop of that excavator, it grabs a volume almost exactly the same as this classroom in the time that you would imagine. It goes crunch, swivel, open, close, open, crunch. Like, I mean, what is that? Like 2 train cars every, I don't know, minute-ish fractions? You know, give or take a minute, I don't know. Big scale. We're talking big stuff. So now, I don't know about you, but to me, that hole in the ground looks suspiciously like a giant funnel. You know, one of my students said, why don't they just cover that with a tarp when it rains? Because, you know, it's a slightly bigger hole than that. So like a 32 square kilometer tarp. When you see that water down there, if that's a copper mine, that's a really powerful poison. Copper dioxide, when it dissolves in the water, makes something that you use to kill bacteria. It's a really strong antibiotic. And it kills almost anything else too. what are you going to do with that lake? And by the way, if you leave it there, it's going to percolate and pollute groundwater. If you take it to the surface, you've got the same problem, except now it's either surface water or groundwater. I mean, what happens when the ducks try to come land there? Like, what happens if you blow one of the containment dam walls and that spills across your preschool yard? I mean, the volumes we are talking about, knowing that the water is by necessity acidic and potentially contaminated with many other things. I mean, if you're mining for coal, imagine those hydrocarbons. Like, these are really large-scale problems. Groundwater, surface water, fires.
What are they currently doing for water?
It depends on what type of pollution they have, but the primary method of dealing with this water is called impoundment, which means you keep it there until it evaporates, and then you package and bury the sludge. They make what are called impoundment dams, which is just scraping dirt away from the center to make a circular hole in the ground, you know? And then you just fill all your water into that on top of a concrete or clay liner. So it can't percolate, let the water evaporate, and you scrape off the sludge. And repeat. I mean, that's an ongoing process. It's usually
like dig the mine deeper, would you have to make a new one at every time?
Or just one next to it. So the real estate of most mines is about 50% impoundment, about 30% tailings, and about 10 to 20% hold plus processing. Does that make sense? About half the land used for large-scale mining is just to hold the water pollution. Can somebody please remind me that tomorrow we will start with strip mines? You may want to write that down, strip mines tomorrow.